Factor trees. Now, the only way to understand factor trees is that you have to know what factors are and what a prime number is. A prime number, it's defined in the purple, and it says that it's a whole number. It's greater than one, whose only factors are one and itself. So we're going to look down here at these bottom numbers. These are all considered prime numbers, the number 2, the number 3, and the number 7. As you can see, they only factors are one and itself. That means the only way to get the answer 2 is 1 times 2. Now, if we look at 3, the only answer to get to 3 is 1 times 3, and the only way to get the answer 7 is 1 times 7, therefore meeting the rule for prime numbers. A whole number greater than 1 whose only factors are 1 and itself. Now, the other thing that you need to understand are what factors are. Now, factors are just merely numbers. So let's look at the numbers at the top to understand what factors are. Factors are, how can I get this answer? How do I get this answer? 12 and 16. First, let's look at 12. Now I'm going to change the color so it's a different color. Now, one way, I'm just going to start at the number 1. 1 times 12. All right, those are two factors on how I can get the answer 12. Then I have 2 times 6. Excuse my sloppy handwriting. And then I have 3 times 4. 4 times 3 is the same thing, so I am not going to rewrite it. Okay, and then let's try 5. Nope, nothing times 5. And then I have 6 times 2, but that's the same as 2 times 6. So that's about it. 12 times 1 is the same as 1 times 12. So I do not have to rewrite those factors. So here, and this always makes it easy to understand. You see this U I'm making with the arrow at the end? That's how I'm going to read the factors of 12. Therefore, the factors are 1, 2, 3, watch this, 4, I'm reading it just like my U, 6, and 12. Those are factors. Now let's look at 16. For 16, we have 1 times 16. We have 2 times 8. 3, 3 is not 1. Then we have 4 times 4. Those are all the factors. Again, we do not have to go down the list and write, oh, 8 times 2, because 8 times 2 is the same as 2 times 8. So there's no need to write that. We also don't have to write 16 times 1 because it is the same as 1 times 16. So what are the factors of 16? You can pause the video and write it for yourself and then check. But here are the answers. It is 1, 2, 4. Now I don't need to write 4 again, so I'm going to go to 8 and 16. These are the two things you have to understand in order to understand factor trees. Now we are ready to do a factor tree. Now here we have factor trees. Now that we've gone over what prime numbers and factors are, there are some rules that we need to follow, which are in red. 1, you cannot use the number 1 when making a factor tree, and you'll see why they call it a tree. It looks just like a Christmas tree. Whenever a number becomes a prime number, you have to circle it. And then when you're finished, which that step we're going to learn later, you're going to write the number in order from least to greatest. So let's first look at the number 10. So I'm going to make my first little mini Christmas tree. Oh yeah, my Christmas tree is going through some things. And all I have to say, what two numbers equal 10? The only thing is I cannot use the number 1. Okay, well that's fine. 2 times 5. Now you can put a little multiplication sign there if you want to, but you don't really have to. The next thing I ask myself is the number 2 prime? Well, yes, it is prime. So I'm going to go ahead and circle it. Is the number 5 prime? Yes, it is prime because it can only be multiplied by 1 and itself. I have finished the factor tree for number 10. So I'm going to go ahead now and go to number 50. So I make my first little Christmas tree, and I can think of any two numbers I want to. It doesn't matter. 2 times 25, 5 times 10, whatever I want to. I'm going to use, let's go 5 times 10, right? So 5 times 10. Again, you can use the multiplication sign or not. Doesn't matter. The next question I ask myself is that number 5 prime? Yes, it is. That means I circle it. I'm not doing anything else to that number. It is frozen. So now I look at number 10, and is number 10 prime? Nope. Number 10 is not prime because it has more than a factor that's just 1 in itself, because it's 1 times 10, but it's also 2 times 5. So that is not a prime number. So I am going to use 2 times 5. Again, I can put the multiplication sign on, but I don't have to. Then I look at those two numbers I'm finished with and I say, is the 2 a prime number? Yes, it is. So I circle it. They're like little ornaments on a tree. I don't know if you see it. Is 5 prime? Yes, it is. So look, I have finished the factor tree for both the number 10 and 50, but there is a next step. All right, so now that next step, I've made a line in between so you can see the difference. I now have to write these numbers down in the order from least to greatest. That's rule number 3. So first I'm looking at the number 10. I'm going to write down the number 2. And you know what? I think I want that in a different color. Let's put that in a different color. I'm going to write down the number 2 and the number 5. Now, when I write these numbers down, I am going to separate them with a multiplication sign. All right, I'm finished with the number 10, and I'm going to move on to the number 50. And I'm going to write them in order. This is going to help, trust me, from least to greatest. So I see 1 2 over there that's circled, and then I see 2 5s. So I'm going to write 2 times 5 times 5. Awesome. Now, this next step is really cool because this involves finding, when we do this second step at the bottom, what we're really trying to do is find the greatest common factor. That means, what number does 10 and 50 have in common? What's the biggest number that they have in common? That number is called the greatest common factor, and it's abbreviated GCF. All right, greatest common factor. So what I'm going to do is I'm going to make a little peanut and I'm going to match them. So I'm looking at number 10 and 50, and these two have their own peanut, right? Every number I can find, I'm going to match it with a peanut. Oh, we have a 5 here, and it looks, that's it. We only have 2 peanuts. All right, so now I'm going to write down each number in that peanut. So the first peanut, that number is 2. And guess what? It's separated by a multiplication sign. And the second number, that peanut, is a 5. And so now I write my answer. 2 times 5 equals 10. So therefore, my greatest common factor of the number 10 and the number 50 is 10. That is correct. That is the greatest common factor. So factor trees, they help you break down and find factors, but they also can allow you to find the greatest common factor. Now, I want you to try these numbers on your own. Just complete the factor tree. Don't worry about the greatest common factor yet. I want you to look at these numbers, pause the video, try to do the factor trees on your own. Go ahead and press pause now. Now, once you finish, just go ahead and unpause and see the answers. Good luck. All right, here are the answers. Now remember, you might have used different factors in your first row, but you should still end up with the same prime numbers that I have. If you've gotten it right, you are ready to move to the next step, which is understanding the greatest common factor. You can do some questions about greatest common factor, but if you're still struggling, just go back and watch the video. All right, here are your next set of questions now to find the greatest common factor. Now, here, you're going to find the greatest common factor. That means first you have to do the factor tree, and then you have to remember the peanuts and find their greatest common factor. Go ahead and pause the video now. All right, and now we are at the end. That means you've worked through these problems. At the top of the line, you can see the factor trees, which is how yours should look. And at the bottom, you see the peanuts. This is where we have to combine. This is when we're finding the greatest common factors. All right. So if you're not at the part and you haven't learned greatest common factor yet, you don't even have to worry about this part. But if you're doing factor trees and finding the greatest common factor, you have to have the peanuts. All right. So realize that in this multiplication, when 2 times 5, first, you do 2 times 2, which is 4, and then you multiply times 5, which equals 20. Congratulations on finishing factor trees and the greatest common factor. Just leave any comments if you need any other video, if you have any questions concerning factor trees and greatest common factors.